What would be the best possible space mission if there were no budget restrictions? Why don't we launch all our rockets from ships in the ocean? What are the stars that formed with our sun, and where are they? And in Q&A Plus, where is the center of the universe? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. John Hoy, given no budget restraints in a hypothetical world and limited to utilizing existing technology, which space mission would you sanction? I mean, it's kind of a tricky question because there's no budgetary constraints, but I have to use existing technology. I mean, I think, anytime you want to take on a new mission, you have to have some technological risks. You've got to be attempting some new technologies that have never been done before. So I'm going to sort of assume that what you mean is like no magical technologies, no fusion drives that don't exist, and no warp drives and things like that. So the thing that I would like to see most in my lifetime is a mission to the solar gravitational lens, where we can actually set up a telescope where we use the gravity of the sun as a natural telescope, and then we get a megapixel image of a exoplanet that would just allow us to see mountains and forests and oceans and cities on another planet that is hundreds of light years away. That would be mind-blowing. So that would be one of the greatest things that we could do. But I think, our current technology right now, we don't have any way that we know to get out to that kind of distance within a reasonable amount of time. We're talking about getting much farther than the Voyagers are right now in a decade, and we don't know how to do that yet. So I would say, I'm going to be kind of boring, but in terms of telescopes, I want to see a space-based interferometer. I want to see, 2 telescopes, maybe in a different wavelength, like near infrared, but that are operating on a distance. They are 100 meters apart. They are a kilometer apart, and they are in such perfect alignment that they can act as a telescope that is the size of the gap between the telescopes. And so it would be as if you had a telescope that is 100 meters across or 1,000 meters across or whatever. And there's some great ideas that you could deploy these on the surface of the moon, and you could sort of dial in their distances so they're absolutely perfect. And that would be just a huge leap beyond Hubble, Webb, anything that anybody is planning. And I think that is feasible. That is, it would cost in the tens of billions of dollars, and would require a lot of engineering challenges to build a proper space-based interferometer. But if we could do that, then we would be able to leapfrog to the next big questions, right? Now we're wondering about, are those volcanoes on that planet, or are those mountains? Right? Those are the kinds of questions we could be asking, when right now we're still at the point where we can't even necessarily observe any specific exoplanet. And we definitely can't directly image Earth-sized worlds orbiting around sun-like stars. So that would be great. And then I think in terms of planetary exploration, I think I want to go to Enceladus, and I want to have a lander drop right at the tiger stripes at the south pole of Enceladus. This is where water is being hurled out into space. And so you could actually go and sample that water and search for some kind of evidence, organic molecules, evidence that life exists under the ocean in Enceladus, and maybe even send a probe down, right? You could actually go down into those tiger stripes against the flow of material that's coming out and try to get down to the ocean down beneath and explore it directly. And, that kind of technology, all the bits and pieces have been worked out, but it's just too complicated, too expensive to actually pull that off. So I think those would be 2 of the most interesting things that we could do here in the solar system in this sort of feasible future. Adam Redwine, launching near the equator saves some energy, but what if you want a circumpolar orbit? Would you want to launch from a higher or lower latitude? So as you said, when you launch from the equator and you're moving in the same direction as the equator, then you get to take advantage of the orbital rotation of the Earth, and that allows you to save a certain amount of fuel or be able to launch a heavier payload. I mentioned, the speed, the Earth's rotation is 1,600 kilometers per hour. And so if you launch a rocket, you get a free boost of 1,600 kilometers per hour as long as you want to go into orbit in the same direction around the equator. But if you want to launch any circumpolar orbit, then you're going to want to cancel out that sideways orbital velocity and then be able to launch more north-south. And yeah, the farther north or south you are, then the less of that sideways orbital velocity you have to cancel out. And there are several launch facilities that are, the Russians do a lot of polar orbits. There are US facilities, and actually they're planning on building one here in Canada that will be ideal for doing polar orbits. But you can still do a polar orbit from the equator as well. It just requires, you have to cancel out that sideways, or maybe you want it, right? So that the Earth is going to rotate underneath you, and you're going to be able to then orbit around from pole to pole and be able to see all of the Earth. There's a lot of other really interesting orbits that people have come up with. There's like sun synchronous orbits. There's a thing called Molniya orbits, ways that you can actually just go around the Earth, retrograde orbits, ways that you can get geostationary orbits. So there's a lot of really cool orbits that you can use depending on what you want to accomplish with your spacecraft. And there are different places to launch depending on what you want to do. Chris Nelsynels: what efforts are being made to discover stars similar to our sun or stars that were created alongside the sun in such a hypothetical stellar nursery? Plenty of work is being done to try to find the stellar siblings of the sun. And there's sort of like two main things that you're looking for. The first thing is that you're looking for stars that have a similar path that they're taking around the Milky Way to the sun, sort of similar distance from the center of the Milky Way, similar orbital trajectory going around the Milky Way. And thanks to Gaia, right? The Gaia mission is the one that has mapped out all of these stars, and they found many stars that have very similar trajectories to the sun, and so could very well have been stellar siblings of the sun, 4.5 billion years ago. And then the second thing is to analyze the chemical composition of various stars. And so there are other surveys that are looking at the chemical fingerprint of various stars, and they're looking for stars that are very similar to the sun. And there have been several candidates, at least one for sure, that has almost the exact same chemical characteristics as the sun and has a very similar orbital trajectory as the sun. And so it's believed that that is one stellar sibling of the sun, but there would probably be hundreds of other stars, if not thousands, just moving around the Milky Way that were once part of the same stellar nebula that the sun was. MouseDestruction: Stirling engines in space? Yes, Stirling engines in space. So like a Stirling engine, and I don't 100% understand exactly how they work, but that when you have spacecraft that are attempting to use heat to produce electricity, like the radioisotope thermoelectric generators, they use this thermocouple to extract the heat from this decaying chunk of plutonium that can turn into electricity that the spacecraft can then use. The spacecraft can get a couple hundred watts out of this decaying chunk of plutonium. But another method that you can extract electricity from a system is to use this thing called a Stirling engine. And I don't know the exact operation. I apologize, but the Chinese have tested out a Stirling engine on board their space station and demonstrated that in zero gravity, the Stirling engine works. And so it could be a replacement for a radioisotopic thermoelectric generator. Instead, you have a decaying chunk of plutonium that is producing heat, and it's extracting heat through the Stirling engine to produce electricity. But there's also another idea that I really like, which is that on Venus, you could land a rover onto the surface of Venus and have its internal parts remain as cold as possible. And the outside of the rover is very, very hot. And then it uses this temperature difference between the outside of the rover and the inside of the rover as a Stirling engine to try to extend the length of the life of the rover while it's crawling around on the surface of Venus for potentially several months. There was a paper that came out a couple of years ago that I reported on where, they proposed that you could have a rover survive for a couple of months on the surface of Venus and not have its electronics fried by taking advantage of that difference. It came into the atmosphere of Venus incredibly cold, and it's still cold inside in this pressure vessel. And then you just slowly let the heat in, and you use that heat to generate electricity to move the rover around. So Stirling engines are an alternative to generating electricity when you have a heat differential. It's time to shout out all the new $5 patrons and above: Brian Miller, Ian Holdsworth, Betsy Eyring, Jasper Roast, Owen Dykstra, Connie Klein, James Fowley, Philip Lillies, and Coggy Flechter. Join the club at patreon.com/universe today. Ivan M. Is the density of a black hole the same in the center of the black hole compared to the edges? So we can describe a black hole in two major numbers. We can describe the black hole in terms of its mass, and we can describe it in terms of its rotation, its spin. Now, you can also theoretically measure its charge, but anyway, its mass and its spin. And from the mass, you can calculate the event horizon. This is the point where the escape velocity to get away from the black hole is the speed of light. And so as you get closer within the event horizon, then the escape velocity exceeds the speed of light. And if you are outside of the event horizon, then the escape velocity is a little bit less than the speed of light. And so light can escape. But we don't actually know what is inside the event horizon of the black hole. Mathematically, you can describe the black hole like the entire mass of the black hole. 10 times the mass of the sun, 1,000,000 times the mass of the sun, 1,000,000,000 times the mass of the sun. You can consider it in a single point, a singularity in space. And then you get, from that singularity, you get the event horizon forming as a size around that. But, if you could actually look inside through the event horizon and understand what it is that you're looking at, what would you see? We don't know. So there's a range of possibilities. One possibility is that the black hole is just right underneath the surface, whatever is, and so think about it, go this way. So if you imagine, say, a neutron star is a ball of neutrons. It is the degenerate remnant left over when a star that is much more massive than the sun detonates as a supernova, collapses in its interior, and the protons and the electrons are smushed together to create these neutrons. And this gives you the neutron star. Neutron star is like the size of a city. They're 10 kilometers across. They're very small. And yet they have an enormous gravity. You would have to be going close to the speed of light to be able to escape from the surface of a neutron star. But if you are going the speed of light, you can get off. And that's why we can see them, because they can shine in radiation. And so imagine, right, you've got this spinning ball in space of neutrons from a neutron star, and you feed it material, and you feed it material, and you feed it, and it gains in mass, and it gains in mass, it becomes more massive. And then eventually you hit this, and at the same time, the escape velocity off the surface of the neutron star is going up. And eventually it will get to the point that the escape velocity meets the speed of light. And you now have a black hole. And so an event horizon will form around this neutron star that is rapidly spinning. And so is what's inside the event horizon still in there? But now you just can't see it because the mass has exceeded the speed of light? Maybe. But maybe when it reaches that point, then maybe it continues to collapse. That in fact, the pressure that is holding the neutrons together is overwhelmed, and maybe it turns into a ball of quarks, or maybe the quarks are overwhelmed and it turns into something even smaller. And maybe it actually does turn into a singularity, that the forces of physics can't withstand this amount of material that is crunched into a density that is this high. And so you can imagine it actually does compress down into an infinitesimally small thing. And so in fact, inside, there is the black hole that has all of the mass of the entire black hole that is down into this one single point. And then the rest of the interior of the event horizon is empty space. But it doesn't matter, because we may never know. There may be no practical way that we can ever probe what is in the interior of the event horizon of a black hole. We might just have to be okay with that. XX Philip XX6541. What are the potential pros and cons of launching rockets from a mobile launch ship like the Chinese are experimenting with? Would it have to be a solid fuel rocket? Right, so the Chinese are experimenting with launching rockets from the ocean. And the advantage is that if you can launch directly from the equator, you get to take advantage of the Earth's rotation. Gives you that bonus 1,600 kilometers per hour of orbital velocity that allows you to either launch with less propellant or carry a heavier payload to the same orbit. And, most of the time, rocket launch sites are as close to the equator as you can get, but still be reasonably accessible on your land. And so, for example, in the US, they launch from Florida or they launch from Boca Chica. Those are places that are quite far south in the US, but they're still pretty far away from the equator. But you still get most of the advantage. You don't get the full velocity advantage, but you get a lot of it. China isn't as far south as places like the US are. And so they have to launch, they launch from as far south as they can, but they've been experimenting with this idea of sending a ship down to the equator. And this isn't the first time this idea has been tried. There was a company called Sea Launch that used to operate out of Los Angeles. And actually they would launch with Ukrainian rockets. They'd have a ship that would control the launch, and then they would have this platform that the rockets would launch from. And then they would tow the launcher down to the equator, and then they would raise the rocket and they would launch it from the equator, and then they would tow the launch platform back to Los Angeles. And they operated for a while, but then SpaceX kind of pushed a lot of people out of the market, and Sea Launch sort of shut down several years ago. And I guess the Chinese are experimenting. And I think, the rocket that is launched from their launch platform, there is a solid rocket booster, but it doesn't have to be. You can have a liquid fuel rocket, whatever. It's just that, it's just if you want to take advantage of it. But you have all of that hassle of getting your platform down to the equator. The other way that people have tried is you launch from an airplane. And we saw this with Virgin Orbit. They had a 747 able to carry an orbital rocket, and it would fly down to the equator, and then it would fly along. And then you get the advantage of the velocity of the airplane plus the velocity of the Earth as a way to decrease the amount of propellant that's required to get into orbit. But Virgin Orbit went out of business because still it's just the cheapest to go with SpaceX. Go with a reasonable first stage rocket booster. It's tried and true, it's inexpensive, it's reliable, it's easy to get your payload to the launch site. It just seems to be the most successful launch platform until fully reusable two-stage rockets come out like Starship. Aaron Ball, do you know about the ISS replacement? Currently, there is no replacement for the International Space Station. There is a potential space station that's being built for the moon called the Lunar Gateway, which is expected to launch, in the late 2020s and into the 2030s. There are some private companies that are planning on building stations in low Earth orbit. Vast. There's a couple of others. And, who knows if they're going to work out or if they're going to go out of business. We don't really know. And so right now, really, when the International Space Station is deorbited in 2030, the only game in low Earth orbit will be the Chinese space station. Hopefully, someone will come up with a private station. My reporting experience over 25 years tells me that private companies that are attempting to do space tourism and things like that aren't very successful and have a high rate of going out of business. So I will be watching and reporting as various people are attempting to build private space stations, and I will also be reporting as many of them go out of business. So stay tuned for that. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, where is the center of the universe? And I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who asked your questions in the YouTube comments, as well as everybody who joined us when we did the live show from which these questions were pulled from. Now, I'm going to talk about one of our space friends who is going through a very difficult time. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Barely Griffin, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, David Gilton, David Matz, Dustin Cable, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Marcel Smets, Michael Purcell, Modzo, Paul Roebuck, Rank Heidi, Robeck, Sean Sargent, Stephen Fowler Munley, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I don't know if you've heard the news, but Dr. Becky has been diagnosed with breast cancer. And this is probably a very private diagnosis, and yet she went on and announced it on her channel and various outlets. And I, had sort of explained a lot of good reasons why she did that. And this is a terrifying diagnosis. It's a tricky disease, and I've had close friends die of this. And so I can't imagine what she's going through right now. But she is a very strong, very brave lady, caught it very quickly, and is sort of doing all the right steps to get it treated. But I highly recommend you go and watch the explainer on her channel. And I think the more important thing is what we can do to support her. Unfortunately, she doesn't have a Patreon, doesn't have the membership accounts on YouTube. I'm going to reach out and recommend that she gets her Patreon set up, because I know people will support her. But maybe the best thing that you can do is to buy her book, which is A Brief History of Black Holes. And that will definitely go and support her. So send her love, and I will figure out ways that, our community can help get involved and help with help covering her costs and her recovery. But Dr. Becky, we love you, and get over this. All right. We'll see you next time.